So what we have is our initial results table here. So this is how it's planned out. We have participants here. Participants are always represented by the letter N. All right, so you might see that scattered around all over the place. In this case, we have 12 participants. These are their scores for their left ear. These are their scores for their right ear. Now we've also calculated the mean. So we have 24 here. We have 28 here. Now, doing a quick kind of eyeball test, we can see that there is a difference between the scores, and the right ear seems to be winning. That, unfortunately, isn't accurate enough for us. And we have to do a little bit of statistical analysis in order to work out whether our results are going to be significant to this level down here. So the P less than or equal to 0.05. These are instructions on how to carry it out, but I'll go through it now. So we have a different table here. We have our participants here, our left ear, our right ear, and I've added two other columns. One is difference and one is rank. Rank just means that we are going to take the difference scores and rearrange them so that they are ranked in order of lowest to highest, and I'll show you how to do that in a minute. All we've done with our difference is we've gone 25 minus 32 equals minus 7, 29 minus 30 equals minus 1. One thing I'm just going to point out here is our participant number 10 scored exactly the same on both the left and the right ear. And what I put here is omit. That basically means that for our calculations, for the sake of the Wilcoxon test, we are going to get rid of those results. That's not cheating. It just means that they're not going to make any difference. So let's take them out. So I've put some ranks in here already for the lowest score, which is 1. What we're going to do is we're going to, for now anyway, ignore our pluses and our minuses. Okay, so we're just going to take these all as just the numbers. And that's how we're going to rank them. So if we look down here, the lowest score we have is 1. And we have 1, 2, 3, 4 of these. We can't give them all the rank of 1 because there are 4 of them. So what we have to do is we have to take the average. So what we're going to do, we have to say to ourselves, well, we have 4 of them. So they are going to take up position 1, position 2, position 3, and position 4, but we need an average. So we're going to add these numbers together, and that is going to give us 10. There are 4 of them, so we have to divide by 4, and that is going to give us 2.5. Okay, so, and that's what we're going to do. We're going to put 2.5, 2.5, 2.5, 2.5. So let's look at the next one. We have a 2 there, and we have a 2 there. So we've got 2 2s. Forget about that minus in front of there. It doesn't bother us at the moment. Now, we have to bear in mind that we have already used up the first 4 places. We've used that up with our 1. So the next one we've got to look at is our 5th place. So we have 2 2s, so that would take up position 5 and position 6. And as before, we add these together, which gives us 11. Then we divide by 2, because there are 2 of them, and that gives us 5.5. So we'll go to our 2s and we'll go 5.5, and we'll go to our other 2, which is there, and we'll go 5.5. Now, let's just quickly rank all those now. So this is 7.5. This is also 7.5. So our 8 will be 9, or 9th. Our 10 will be 10, and our 27 will be 11th, because it's the highest. Now remember that we forgot about these positives and negatives here. Now we need to put them back again. So that is a minus, that is a minus, that is a plus, that is a minus, that is a plus, that's a minus, that's a minus, that's a minus, that's a minus. We've taken that one out of our scores, so we'll ignore that. That's a minus and that's a minus. What we've done here is we've added up our minus scores and our plus scores. So if we added up all our positive ranks, so that would be 5.5 plus 7.5 is 13, and then we would add up all our minuses, which has given us 53. What we're going to do is we're going to take the smallest of those figures for our test. So that's going to be 13. So T is 13. That's what we need. This is what we need to see whether or not our results are significant. Now we need to look at how many participants we've got. So remember, N always represents the participants. We had 12, we started off with 12, but we now have 11 because we've taken that score out. Which means that we are left with 11 differences, or 11 participants. Now what does that tell us? We now have 2 main figures. We have a value of 13 for T, and we have our 11 differences, or 11 participants. This is where this table comes in. So let's have a look at this in a little bit more detail. That's the table. It's a slightly different table because there are less participants, but it doesn't matter. So, how many participants did we have? We ended up with 11 participants. And we are doing a one-tailed test because it's a directional hypothesis. We have a figure here. This is called our critical value. And our critical value for this particular experiment is 13. So let's go back to this and let's have a look at this comment here. So remember, our critical value is 13. It's just coincidence that our 13 is the same figure as our t. Don't worry too much about that. Look at this comment here. If the value of t is equal to or less than the critical value, then the difference is significant to p equal to or less than 0.05. Well, what conclusions can you draw from that? The conclusions you can draw is that we can accept our alternative hypothesis and reject our null hypothesis. So this is quite good because we've managed to prove to a significant degree that people are going to recall more accurately information that's entered their right ear than has entered their left ear.